Hi guys, BuildZoid here, and today we're going to be taking well, we're not going to be doing a PCB breakdown, that's for sure. So, because I've already done this one for Gamers Nexus, but basically today I watched the video from Der Bauer about overclocking RTX 2080 Ti's on LN2, and in that video he said that, they weren't able to quite lift the power, weren't able to remove the power limit all that much. So, I have a solution, I think. Well, actually, no. I know for a fact that I have a solution because the way the power monitoring works on all the Nvidia cards is the same method. They've upgraded the chips, definitely. The new cards use different chips to do the power monitoring, but fundamentally the way the power monitoring works is always, doesn't change, and it's very, very easy to trick it because of that. So then, here we have an RTX 2080 Ti Strix PCB because that's the card that Der Bauer was working on in his video. So, the problem at hand is these three shunt resistors. And so in his video, Der Bauer basically said that they tried to replace tried to put a 5 milliohm shunt on top of the existing shunts, and as you can see, it says R005, so that's basically 0.005 ohms. So this is a 5 milliohm shunt resistor, and so if you put another 5 milliohm shunt resistor on top of that, what you're going to end up is with 0.025 ohms, effectively. And the idea behind doing this is that, well, if the resistance is 2.5 ohms instead of 5 ohms, you're going to measure your power limit is going to essentially be twice as high. The problem is they actually tried to do that, and the card went into safety mode. It was stuck at like 300 megahertz or something like that. I don't know where I think it's 300 megahertz. I'm not sure what the safety mode looks like for a 20 series. I don't have a 20 series card. I actually haven't even the only card I've ever triggered safety mode on is a GTX 590. That one also has current monitoring shunts. So yeah, I've triggered safety mode on one of those. But anyway, so they triggered safety mode, and the card basically, you couldn't run at full load because of that. And so it's just like, okay, so how do you remove the power limit without the card, going into safety mode? Well, it is rather simple because if you look at the back of the card, oops. Well, I mean, so on previous cards that used the INA 3221 current monitoring chip, I would have said, I had one method of doing things, and it was rather easy to do because the INA 3221 didn't look like these two guys here. So these are on semiconductor NCP 45491s. And these are the same exact, these do the same thing as an INA 3221, except these have a lot of little SMDs around them instead of just, a couple big ones. Well, it's actually not like big ones, but bigger ones than this. So INA 3221s are really easy to modify because there's a great big capacitor. There's three giant capacitors around INA 3221, and those are the filtering capacitors for each of the power monitoring circuits. But, not so with the NCP 45491s, and also you'd have to do like with a multimeter, you'd have to figure out which of these guys is hooked up to which of the shunts, and that's all a massive pain. We don't want to bother with any of that. We just want the card to think it's not pulling as much power as it's really pulling, and there's a really easy way to do that. So you see the shunt resistors on the front here. The whole idea behind the power monitoring is that you basically have plus 12 volts, right? Then that goes into the shunt resistor, which is just a resistor. So there's your shunt. Then we have the VR. Then we have basically the card. The entire card is after the shunt resistor, and then it goes back to ground, right? So basically the idea is that if you're going to push, say, 10 amps into the card, so you're going to pull 120 watts, right, which is 10 amps, then you're going to be pushing 10 amps through your 0.005 milliohm shunt resistor. I mean, 0.05 ohm shunt resistor. And what that's going to do is that's going to give you a 50 millivolt voltage drop. So if you were to measure the voltage right here, it would be, say, 12 volts. And if you measured the voltage right here, it would be 11.950. Am I correct about that? Yes, I am. So you'd be seeing 11.95 volts on the other side, right? And that's caused by that shunt resistor. And what the chips on the back of the card do here, the NCP 45491s, they basically just they take this voltage measurement and they calculate how much current is going through the shunt based on the voltage measured and the assumed value of the shunt, because basically when you build the card you program the NCP 40 well, actually you don't even need to tell the chips what's there. Basically the chips just report the voltage to some other chip, and somewhere along the line there's something that knows there's supposed to be a 5 milliohm shunt resistor, and if there's 12 volts on one side of it and there's 11.95 volts on the other side, that means there's 10 amps going through it. So that's basically how the circuit works. And see, this is not very complicated. It's not very bright, and it's rather easy to trick, because what you can do if you lift off one of these shunts is you're going to see something like this. And this is obviously not an RTX 2080 Ti Strix, because I don't have one of those, but I do have a GTX 980 Ti, which conveniently enough had 5 milliohm shunts and doesn't work, so I didn't feel bad about just pulling off a shunt resistor just for the sake of taking this photo. But the reason, the importance of this photo is that this is what's under one of these shunt resistors. And basically what we have here, so on this side, this goes to the PCIe slot. So PCIe is on the other end of that. And this goes to VRM. This goes to the VRM and the rest of the card. And so what are these tabs for? Because the shunt resistor sits on top of this like so, right? That's how the shunt would sit there. So these go off to the INA 3221. So this is high voltage. So this is the high INA 3221. Well, this is the higher voltage side because there's not that much voltage drop across there. But high, and then you have the low side, which is also going to the INA 3221. But it really doesn't matter what the last, what's important here is it doesn't matter if you have an INA 3221 or a, NCP 45491, because the shunts always are hooked up like this. Always. So if you want to lift the power limit, if you want to disable the power monitoring, you just need to bridge these two right here, right? Just connect those two together. And then you need to run a clever little, and that's plus 12 volts PCIe. Then you need to run some clever wires into this, and they're not that clever, because what you're basically going to do is you're going to do this. Resistor, plus 12 volts, another resistor, ground. And the important part is the values of these resistors. So on my 1080 Ti, if you remember the 1080 Ti Buildzoid edition, what I'm running on that card is a 33 ohm, and 120k ohm, and you know what, I should really use the symbol there, and 120k ohm resistor. The end result is that you basically get roughly, if you have 12 volts on this side, then on this side you get 11.997 volts. 997 volts on this side. And the end result is that basically the card thinks that there's always a 3 millivolt drop across where the shunt resistor was. And the end result of that is, well, the card always thinks it's pulling slightly less than an amp on that input. So very easily for a Strix, you would just pull this shunt, pull that shunt. I wouldn't really worry about this one, though if you wanted to, if you're going to be doing this, you can actually rewire the 12-volt power planes completely, because you could, in theory, you could lift off this shunt, and there's nothing really, there's no reason you have to bridge it like this, okay? You don't need to do that. If we cross that out, right, let's say I didn't bridge it like that, I could just drag this off to, we can't see the rest of the card on the other end there, but this could literally go to any other, we could just shove any other 12-volt source into that, right? Any plus 12 volts, if we wanted to, can just go right into that, and that would be fixed. You could rewire your power planes doing this if you wanted to. So yeah, for a Strix card here, it's lift the shunts off, and then you're gonna, if we look at this one, you're you're going to have one big tab. You're going to have the little tab, right? And then, actually, I think I got that backwards. You're going to have the little tab there because the big tab's obviously down here. And then you're going to have the big tab up here. And then you would just bridge across there. And then, you know, how are these connectors oriented? I don't know. I don't care. Okay. Actually, you can also just bridge this side as well. You can do that. And then you'd run, you know, your resistor, your other resistor, pull that to ground, like grab that, pull that to ground over here. You're going to fix it there. That's a ground. I mean, there's other grounds, like these have grounds, but I'm not sure which side those are on. Because, yeah, I don't remember the pinouts. I usually use Wikipedia, so... if I kill anything someday, it's going to be because somebody edited a Wikipedia page I used. But so basically at this point, you'd have like 12 volts, you know, that would sort your 12 volts out there. And then you'd run a wire from there to the little tab here. And then on this shunt, you can see that you actually have the same kind of layout going on. So you would just take, you know, again, bridge these two, bridge across there, grab this, push it into this tab down here. There. And you would just run that, and you could have a 33. If you wanted a bit more, like, because I'm not sure where exactly the cutoff would be, but I use a 33 ohm because that's slightly under an amp. But if you use like a 40 ohm or, well, like a 47 ohm resistor, that would still work. You could totally use a 47 and then still use like 120K on the other side. And bam, like there's your shunt mod. And you don't have to do a whole bunch of very fiddly soldering around these two suckers. Because like the other option is that you just screw with these guys directly instead of like messing with the shunts that they're monitoring, but like both methods work just fine. And after you do this, it's bye-bye power limit, because at this point the card doesn't actually know how much current it's pulling. It just thinks it's pulling whatever you just told it it's pulling. This guy, you know, if you wanted to be fancy, I'm not sure which side of this resistor is the input and which side is the output. If I had to guess, I would think it goes like this and into the inductor over there. Because doing it the other way around just doesn't make any sense, because it has to go to like the VRM over here, right? And that would be really silly. So I'm going to say it goes like this. So you could just remove this, you know, remove this shunt, grab this, pull that all the way to, well, you could run like a pretty, like you'd have to run a pretty fat wire for that, but you could then reroute this tab to like whatever other 12 volt power source you want. Say one of these 8 pins. So yeah, it's really like Nvidia's, in some ways, it's kind of funny. On an AMD card, if you want to physically modify the power limit, God help you, because AMD monitors the power going through the phases, not the power going into the card. And so it's really hard. Well, it requires a lot of soldering to actually lift the limit. And the other thing is you actually end up screwing with the control loop of the VRM, because the voltage controller uses the per phase current monitoring to know how to balance the phases. So if you start screwing with that, the VRM starts running a bit, like you could potentially get the VRM running a bit weird. Or very weird, or like straight up malfunctioning. Whereas with Nvidia cards, yes, this is a much more accurate current monitoring system, but it's also way easier to disable, because it's just resistors. Like, it's just using resistances and fixed voltage values. It's not monitoring, like, well, more importantly, it doesn't affect the bloody VRM when you mess with this, right? The VRM really couldn't care less about what's going on with these shunts. They're not part of its not part of what it has to worry about. So yeah, you could lift off the power limits like that. And then I assume the power balancing, because the new Nvidia cards also have a bunch of fancy power balancing circuitry, which might get triggered after you mess with all the power inputs. Like what I'm thinking by triggered is like it might disable it, like it might not power balance the VRM properly anymore. And if that ends up happening, well, I'd actually have to have a card in hand to figure out what to do about that. Because again, it's just like this is working with the limited information I have from the internet, but it's just like I rather like shunts. I rather like Nvidia's power monitoring implementation, because if you need to disable it, it's pretty easy. And this is actually a way more, like on some cards, this is actually inconvenient, because like some cards will have like like the 980 Ti, for example, right? That one's 8 pins are laid out like, I'll just draw it. So you have the power connector, right? With the wires coming out of it. And then you have the shunt, and that's all cool and all. But then there's an inductor right here, right? Which is just like, okay, so how the hell do you get to the shunt when, you know, it's next to this massive component? So, like, the easiest way to deal with that would be, like, you'd have to desolder that, and then that would be a pain. But on a card like the Strix, I mean, you can easily get to these guys. Like, just remove the bloody things, and then rewire them a bit, because the card won't be any the wiser about what's actually going on with its power consumption afterwards, or use a 33. And this exact setup basically is how my 1080 Ti, the Founders Edition 1080 Ti that I fixed, that card thinks that it's always pulling roughly 15% of TDP all the time. It never ever pulls, like, never ever thinks that it's pulling more power than that. And that's really neat, because it doesn't have a power limit thanks to that. So, yeah, unfortunately it does mean that Nvidia has disabled just putting a shunt on top of the existing shunt, which I'm actually surprised they've gone that far, because that's like, that's pretty excessive in my opinion. You know, like, but yeah, this should still work, because ultimately you're just gonna, like, you might just have to tweak the reported power limit up until it matches what the card thinks it's supposed to be pulling. You know, you could potentially make the card think that it's always pulling a 200 watts or something, because unless Nvidia actually went and based the safety trigger off of, like, is the card pulling X amount of power at idle? Check. Is the card pulling X amount of power under load? Check. Unless they do something like that, as long as you don't feed it too low power values or too high power values, you shouldn't have a problem. So basically something like 15% should work fine, 20% should work fine, you know, 10% would work fine. Really, even 50%. Like, as long as you're not hitting 100% of the power limit, or like 0. What, maybe like 0.5% of the power limit or something like that, you shouldn't have a problem, really. So, yeah, that's kind of that. You can disable the power limit like that. I'm actually surprised that, you know, Der Bauer, and because he, like, in that video you can see Elmore sitting behind him, and I assume they're at Asus HQ. So it's just like, I'm really surprised they didn't do something like this, because it's not that difficult, you know, to do this. And this would totally eliminate the power limit. Like, if you do this, there's no power limit left whatsoever, because the card doesn't even know how much, like, at this point, the card isn't even measuring how much power is going into it. So, yeah. Man, I really wish I could get one of these damn cards to play with, just to disable all of Nvidia's fancy power management stuff. It's like, that's the most interesting part for me of any Nvidia card these days, is just like, how can I disable all of Nvidia's stuff? I actually picked up another 1080 Ti to work on, so yeah, that'll be interesting. I'll actually be doing this, I'll actually, for that 1080 Ti, I'm going to be doing the power modification this way, instead of, because it still uses, like, it's a palette card. It still uses an INA 3221, but just for the sake of demonstrating that this works, when I work on that 1080 Ti, I'm going to do it this way, with the whole sort of the, you know, go over the shunt like that, then like this, then add the resistors, and do it that way, because it's not that, like, it's literally just a different attachment point. It's not any different from the modification I run otherwise. So yeah, anyway, that's it for the video. Oh man, I've made it unnecessarily long, but yeah, Nvidia power limits. They seem to just be pushing more towards, like, forcing people into my method, which is just like, this is just what I've always been doing. Because every single card from Nvidia, actually not every single card, but no, every card from Nvidia that I've power modded and actually, like, run seriously, I've done this. Because this is just, in my opinion, the best method. Because it's no longer a matter of, oh, the card thinks it's pulling a lot less power than it should be. It's just like the card doesn't know. It just doesn't. So it can't complain about what it doesn't know. So there, that's how to that's a slightly easier way of doing, like, applying the permanent complete power limit removal for a really any Nvidia card unit using power monitoring shunts on the inputs. Incidentally, if you go far back enough in Nvidia's GPU library, like to the really old cards, they don't use this kind of power monitoring system. So for something like the 200 series, I don't think this would work at all, because I don't think those cards have shunts whatsoever. Yeah, the modern cards, you just do this and bye-bye power limit. Admittedly, just this is quite a lot of work for a lot of people, but it works really well. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave a comment, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, and there's also t-shirts you can buy. There's a link to both, link to all of that down in the description below. And yeah, hopefully I'll get my hands on a 20 series GPU before they become irrelevant. But knowing my track record for getting hardware in a timely manner, that's probably like wishful thinking right there. So yeah, still, that's it for the video. Goodbye. Where's the stop button? There it is.